So this is our first session for Model Mayhem by me. Some background information of what we're going to be doing today is the organ and function. The organ in question is a trachea. So what is a trachea? It's a windpipe, basically, and whose function is to channel air to the lungs for oxygen diffusion. Other secondary functions include maintaining air temperature, humidity, and trapping airborne particles. And you can see here to the right, just a diagram of how the trachea is. It has these tubes called bronchi. So you have primary bronchi, which is the first right and left segments, and those branch into smaller segments, leading to the terminal alveoli, which is where oxygen diffusion occurs. A little bit about the structure. It's a U-shaped cross-section. The trachea, composed mostly of cartilage and muscle. And so it has these rings, and these rings are what provides it the structural support, the hyaline cartilage rings. And like I mentioned before, it has these branches called primary, secondary, and tertiary bronchi, and it ends at the alveoli. And to the right, we have an image of the angles produced by the primary branches. And so for some people, it's inversed. They have the lungs inversed. But these are usually the angles 20 to 30 and 45 to 55. So a cross-section of the trachea. You can see that the trachea is in front of the esophagus. So this actually produces some complications down the road for people that have, let me see if I remember, tracheoesophageal fistula, where it has a channel that comes into both the esophagus and the trachea, connects both of them, and that usually occurs in pediatric cases. But just so you can get an idea of how the cartilage and muscle tissue that surrounds the trachea looks like. So air will pass through that and then reach to the lungs. So what can go wrong with a trachea? A certain couple of cases can go wrong, but in most cases, the bottom line is that the structural support is compromised, where the air does not reach the lungs that it's supposed to reach down to the trachea. So some of these cases include tracheostenosis. So if there's obstruction or the trachea is too compressed and can't channel that oxygen. You have tracheoesophageal fistula, which is actually here an image to the right, are certain cases, the most popular cases of fistulas that occur. Basically when, like I mentioned earlier, there's a channel that opens between the trachea and the esophagus, and mostly in pediatric cases. So they afterwards have to go surgically remove it and modify it and find a way to connect it to the esophagus as it is in normal anatomy. You also have obstruction and tracheomalacia, which is when the cartilage, there's a cartilage issue that makes it weak and not structurally sound. So it falls within itself. And of course, tracheal cancer. But for most of these cases, it pertains to structural support being compromised. I don't think with the exception of cancer, that's not really helpful there. But the treatment that can be used for that would be a tracheobronchial stent. And so it's going to basically open up that passage for the trachea. And particularly one product that's used is Boston Scientific Dynamic Y stents. So this is a product to the right, just to get an idea of how it is to scale. Pretty small. But this is put down someone's trachea. So they usually get a what's it called? A bronchoscope. And bronchoscope just takes you all the way down to the trachea. And they slide it in there with some forceps. And this is a brief case study so you can look at exactly how they do it. But for today, what we're modeling something similar to a tracheobronchial stent, and based off Boston Scientific's Dynamic Y stent. And here are the features they'll be incorporating. So this is available online on their product information description. Right, so with that, let's get started. I'll be switching over to SolidWorks now. So can you guys see SolidWorks? All right, yes. So first you want to do when you're in SolidWorks, if this is your first time using SolidWorks, let me give you a brief overview of how it works. So this here, that's this window in black is called your window pane, or your graphic window. And it's where you see most of your objects. Here to the left, you have your family tree or your history design tree. Basically shows you all the features you had in this part from beginning to end. So this would be at the top, the earlier features, and down to the bottom, you can see later features incorporated in this part. And if whenever you want to go back a feature, you can roll this icon, this bar, roll it back up to suppress the features you had in that sequence. And so you can see how this part was made in progression. So that's useful. It's called the rollback feature. Okay. All right. Up here to the top, you have some tabs with your features. Most of the features you'll be using are within Sketch and then we'll be using some features within extrude, within here, the regular features tab. And for rendering tools, we're going to be using some rendering tools to make it look nice. Here to the top right, we have our command prompt. So if you want to search a feature, you don't know where it's located, but you know the name, we're going to search it here, type in whatever feature you like. Section properties, just to give it an idea of section view. Let's begin search features. So let's begin. The first thing you want to do when you begin is obviously open a new part. So we're going to go open a new part and start from scratch. So this is a new scratch part. A little bit of information from the notes that we had in the PowerPoint. Basically, we have a trachea, and then we have some angles. So we're going to start our sketch from the top section. So this is the top section of our entire model. Sketch on the top plane. We're going to do some lines with some angles. Before we finalize this drawing, you want to make sure you're using the right system. In this case, you look here to the top, the bottom left, right. It says unit system and MGS. So this is correct because we'll be modeling in milligrams, in millimeters. So that's good. So now we draw the outline of our stent, which is basically just a Y shape. And then include some reference lines. That's why you have these solid lines and then these reference lines. Reference geometry is dashed, and you just use that as reference. And solid lines you can actually use to build stuff. Let's add some dimensions to this. If you remember in our PowerPoint, this was 110. This was 20. And this was 40. This was actually 25. So now we have our lengths correct. Let's go ahead and add some angles. This was somewhere between 20 and 30, correct? So we'll add 25 degree. And this side was somewhere between 45 and 55, so we'll add 50. Drag our dimensions. And how does that look so far? Let's add another reference line horizontally, and then we'll make these two reference lines equal. So now we have solid line here, and a solid line there making our Y shape. This is what we currently have. So now let's go ahead and include some planes. So to draw some reference planes, go here, search up for reference geometry. In this case, it'll pop here to the left, the extreme left bar. This is a tool or a tab. Include plane. It's going to ask us what reference geometry we want to reference it to. And we want to be able to draw at the ends of this Y stent. So let's start here. I'm going to choose this point. And then we're going to choose a line. And there's our line. We have built a plane based on a point and a line. And we know this is a correct plane because we want it to be coincident and perpendicular to our reference geometry. We're going to repeat this process. And so now we have our two planes. So what's next? We're going to draw on these planes. And so let's draw on the big side first. We go to our sketch tools and we'll draw a center line, choosing our plane number 3. So right now we're on this plane. We go to origin and we just start drawing. And now we'll add some dimensions to it. So if you remember our dimensions, we wanted it to be the tracheal diameter 15. So we'll divide that by 2. And then we'll make this 15. And now to draw the cross section of our tracheal stent, we're going to use a spline tube. So a spline tool is useful compared to other shapes because spline tool allows you to draw complex geometry as compared to arcs, which is only 3 points, or in the shape of a circle or a curve. So overall, if you want to draw some complex geometry, go ahead and use spline, which we'll be using here. And once you're good with the outline you drew, you're going to click escape on a keyboard. And this is a spline. You can also draw style spline and equation-driven curves. So if you want to mathematically figure out what's the shape of the cross-section that you're looking for, you can do that and just type it in here. And it should give you the exact same shape. So now we have our sketch. We're going to mirror it. Mirror about this line. Starting to look a lot like a part of the dream, right? But we're not done yet. We're going to make these tangents. So it can be converted to tangent because it already is. But these can be converted to tangent. Yes. So they're tangent now. Like this one. There we go. Now they're tangents. Cool. Let's do offset entities. And offset entities, what it does is going to get our sketch and it's going to offset it by the required distance we inputted. So we're going to offset this by 1 millimeter. And you can see we have our inside, which is approximately 15 in diameter, 15 millimeters. And then we have our outer shell. And while we're here, let's go ahead. This is good. Let's go ahead and offset these one more time. So what we have so far, we have our straight sketch, and now we're going to extrude it. Actually, before we extrude it, let's go ahead and finish drawing the other sketches. Same procedure. You just want to include your reference geometry first. This should help you. So what was the diameter for the smaller branches? It's 12. So we'll do 12 divided by 2. And then do 12 here. And then we'll do spline again. And let's say you want to modify the spline. So the spline, you have the position you can change, and you also have the curvature. So see how you have 2 arrows? That would change the curvature. And you have this middle section, which is going to change the position. Much better. Mirror entities. And then we'll set these tangents. Cool. So now we have our sketch done. And I'll show you in a second why we don't need this sketch plane 2. So let's go ahead and click here, good, and hide this. So we're going to hide sketch plane 2. So now what you want to do is extrude. Go here to selected contours, and you just choose the hollow section. In this case, you can sketch within these options. Up to the vertex, you could choose this vertex, or we're going to sketch blind. It's going to be any distance we want it to be. We're going to sketch to 105. We're going to extrude to 105. I'm going to repeat that process here. All right. So you can see we extruded up to this vertex. Let me go ahead and show you something. We're going to hide this part number 1. And we're going to edit this extrude so we can extrude through all. And then instead of having to draw this exact same sketch over to the other axis, we're going to move this part. That way we have the identical sketch because it's coming from the same part. To do that, we need to add an axis, a reference axis. So we're going to go here to reference geometry, click axis, and we're going to create an axis from 2 planes. We're going to include the front plane and the right plane. And when you connect these 2 axes, these 2 planes, you get an axis. There's your axis point. So now we can move this body. Cross section number 2, we're going to move it so it can align to this axis. We're going to go here to rotate, and we're going to choose our axis of rotation. Once that's done, we're going to rotate it and the other way. So I knew it was 25 to begin with. We're going to rotate until it reaches. Let's align with this line. And you can see we have one more body, in this case, body slash move slash copy 1. So now what we want to do is we want to repeat that one more time, but repeat it in such a way that this body that we created is going to align to the end of this dot. So we're going to create a mate setting. We're going to align this face to this point, and that's good. So now you can see we have our hollow tubes, and they're in the position that we want them to be. What's next? We have hidden our 3rd tube over here. This is our 3rd tube, it's hidden. We don't care about this right now. We're going to do an intersect. Intersect between bodies. So by doing an intersect, we're going to just keep what we want and leave what we don't. So now we have a finished part created by the intersects of all these bodies. And we still have our solid body over here, which is the 1st tube. We just brought it back. What's next? So now you want to connect them. And right now you have this big gap in the middle. But you want to connect it in a way that this sketch profile can merge onto this complex surface. And right now we don't have a way to do that. So we're going to add a reference geometry. We're going to add a plane, and we're going to do it along this axis. Second reference. Right. So we're going to add a plane along that axis, but we're missing a sketch to do that in order to actually add this plane. So the first thing we're going to do is we're going to add a plane, but we're going to add it to this face here, directly on this face, so 0. So now we have our plane on the face, on the end face of this main pipe. Let's sketch on it. And we're going to sketch in a way that we don't have to repeat this line. We just click here, convert entities, and choose the silhouette, or in this case, the sketch we want to convert. And there, it already converted it for us. So you can see this black outline. It already did that shape for us automatically without having us to repeat this line. Right. The next thing we're going to do is we're going to add a reference line on this axis. Right now this is an axis, but we want to add a reference line to this axis so we can include the plane. Sketch on our right plane, put a center line from here to here. And that's good. So now we can go back to our reference geometry, include plane, for second reference. I think we'll include one of these, the right plane. So here we were able to include the angle at which we want to create this new plane line. So a nice number would be 80. Just a nice number. We create an axis 80 degrees. And this axis is going to connect this face to this part. And I'll show you how. The next thing we do is we get our plane number 5 and we draw a sketch on it. And now you want to convert entities and choose the outer surface or the outer curves of the intersect we made. And see how they're projected onto the plane that we had. Let's go ahead and save for now. All right, so now we remove the body part. It's hidden. And now we're going to create a sketch to connect these two parts together. First, we'll finalize this sketch here, so we can finish the closing sketch. And for here, we have our converting entities to guide us, but we still need to make a spline to finish the sketch. Let me hide this axis. Let me also hide this sketch. And we can see we only have sketch 6 now. Let me also hide this one. So now we have plane 5 and sketch 6. That's all we have visible on our screen. Let's go ahead and finish this spline. There we go. And we'll mirror this spline about this line. Go up here, make these tangents. They're tangent now. And go down here and make these lines tangents. And now they're also tangents. So let's finish by offsetting this chain, and we're good. Let's bring back our bodies like this. So we're going to create a loft, and a loft is going to connect this sketch with this sketch. Let's try it out. You see how we have a loft? It's going to connect these two parts. But right now, if you notice, it's straight. It's a straight loft, meaning you look at it from the side, it's just a straight loft. Nothing wrong with that, but we can add guide curves to make it more structurally sound. That way there's no sharp edges or corners. So we go back, this is your loft. We're going to use our rollback feature now. We roll back the loft, and we go back up here to our bodies and bring them back. So if you notice, when we had the loft, this is how it looks like. Since we're taking away the loft, we're going to add here a sketch. Let's go here to sketch 5 and move it down below plane 5. And then we're going to go to sketch 5 and edit it. And we're going to edit it by incorporating a 3-point arc. A 3-point arc from here to here. Another 3-point arc from here to there. And now let's add some dimensions to these arcs, since they're fixed now. 100. 30. And we'll edit the bottom. Yeah. Let's edit this one at the bottom. So we have a dimension to it. Radius of curvature. Case 5 as well. And you'll see the difference it makes once we have these sketches added. So we're going to go back to our loft, and we're going to edit our loft. And we're going to go here at guide curves. And we're going to select our sketch number 5 for the guide curves. So I'll show and select the lines on the guide curves. Yes. All right, let's go back into the loft. Try it again. We have our lines here, our open profiles. Going to go here to our guide curves. And go here to our bottom guide curves. And now you see the difference? By adding guide curves, you're connecting both parts, essentially. But right now it's solid. It's a solid part. If you stick away, go back and unmerge these features first of all. We're going to unclick merge results. That way they're separate bodies. And I'll show you right now. Let's hide these bodies. So right now our loft is a solid piece. It's not hollow. We want to make it hollow. Let's bring back our body parts. This is how it looks like right now. So what we're going to do is we're going to make it hollow by shell. You see this? We're going to shell this. We're going to make it so that it shells to 1 millimeter thick. And there it's done. Let's bring back our parts. Shell inward. And there you can see the result of the shell. But we still have the parts, some excess parts from the other bodies that we can remove. Let's go ahead and do that. We're going to do intersects. So we're going to assume that we did intersect. In this case, the only thing that will change is we remove this bridge. So let's go ahead and bring our bodies back. So by doing intersect, we'll be removing this part, this intersection piece. That just doesn't look good there, because you want the channel to be open when you're having when you're putting the stent in. But now what we're going to do is we're going to add some fillets. You know, fillet on this face, and this face. And we'll do 150 fillet. There you go. 150 fillet. And a feature. So you can also fillet this part here. One thing that would help with making our fillets is before we actually fillet, let's combine these parts. And then it will be one body instead of multiple bodies, because you can only fillet one body at a time. And when you do start your fillets, start with the largest ones. So we're going to go ahead and fillet those largest edges here. This looks pretty big. Let's also fillet this edge here and this edge here. And we're going to fillet this at 1 millimeter. Half millimeter then. And now we fillet it. And we can also fillet the faces that we had earlier. Like this one. And this one. And now this one, since it's all one body. We move our rollback bar, and we can delete this feature now. All right, so what's next? What's next is we want to be able to add rings to this tracheobronchial stent. To do that, we'll be doing a sketch. So let's go here, reference geometry, add plane, and we're going to reference our geometry from plane and 100 millimeters away from our plane, but in the opposite direction. So that way it's here. That's our plane. Let's make it 100. We're going to add 26 rings to it. So we have 100 millimeters to work with, divided by 26, 3.8. So we'll add 10 minus 4. 106. We're going to, leave it 106. Now we draw our sketch there for a cross section. And to do that, we'll just create a sketch here. Convert entities of our previous sketch that we had here on sketch 2. And now it's all projected on the new plane that we have. And there we go. That is good. So then we go to features, sweep. We're going to do a circular path, sweep. And we want it along this open group. That's right. The thickness we want this to be is 1.15. And click OK. Now we'll be mirroring this on the other side. We want to mirror along that face. We want to mirror this body. Let's go back to it. Options. And click results. And then now when we go to our mirror, we can select just this body to mirror along the other face. And there we go. So now we're going to combine those two bodies, specifically these rings, and add them. So now they're one body. Add this plane, and we're going to do a linear pattern of this entire body along this direction. So we said it was 100 millimeters. Say we're going to do 25 or 26. But since we're spacing it every 4 millimeters, it's better to do 25. And we're going to linear pattern this body. We don't want it to merge, so I don't think it has merge result here. And there we have our linear pattern. Now what we want to do is 26 solid bodies that combine and a lot of linear patterns. So this is a stem so far. Now, what we want to do is actually make this the right material properties. So we go here to material, get material. It's going to bring up a different array of material databases. In particular, we want to add silicone. So now all this would be a solid body of silicone. And we know that's not true because we have stainless steel rings in it. But just for the sake of simplicity, we're going to make a silicone. So if you want to make solid simulations in SolidWorks, you can do that. Now we go change our appearance. So the difference between materials and appearance is right now, this is a silicone tube, everything. But we can make it look as if it's stainless steel for the parts that we want to render as stainless steel. But it will still be silicone. So we go to our appearance and we change the appearance of the plastic to make it look clear. Translucent plastic. We apply it to the parts we want. Glass. Select bodies. I want to select this body. So we go ahead and select that body. And now we want to repeat the same process, but with all these linear patterns that we did, we want to make an appearance of metallic. In this case, stainless steel. So we close plastic, we go to metal, steel, polished steel. And we'll click polished steel. Bodies. solid bodies. So basically, you just select all the different linear patterns on this part. And then here, almost done. It should apply the appearance you want to see, which is steel, polished steel. Let's give that a try. Nice. So polished steel is applied. Next thing you could do is you want to change the scene. So you can change the scene here to render tools, edit scene. We're going to choose some basic scenes. In this case, it's going to be a studio. We're going to choose reflective floor black. It's a nice one. And there you go. There is your finished part. Now all that's left for you to do is you want to preview it before you render it. So give us a minute for it to initiate the preview window. So that's our image being made right now on the rendering screen. It's the workspace that we have available. I guess the only thing I'll be missing for this is you want to intersect it to remove that bridge. But besides that, this is how your stand would look like. Just keep in mind, now, even though you were able to make it in SolidWorks, this is just the first step. Then you take it to manufacturing, find a way to make this in production. All right, so now it's done rendering. And basically you would know it's done rendering because it indicates you at the top right of the screen that the render process is complete in terms of percentages. And you're still able to see this correct. So now you can see the final image rendered. What you want to do now is you want to save it. So you save the image and you give it a nice name. So it's saved. And I'm going to switch back to the SolidWorks screen. Now that the rendering process is complete, we pretty much reached the end of our session. Key takeaways for today is you learned, well, let's list the things you learned. You learned how to do sketch, particularly how to do spline sketching. You also learned how to do linear patterns. You also learned how to do intersections. You learned how to do lofts. And when necessary, you learn how to troubleshoot because there's always bound to be problems when you're modeling. And it's a matter of practice.